So here, we're going to use Cramer's rule to solve this system of equations. Zoom out. To use Cramer's rule, you want to know what the determinant is first. So, in fact, we'll set this up for that. We're going to look for just the determinant. That means you're going to set it up with the vertical lines. And for this first part, you're only going to look at the left side of the equations, where we have x, y, and z. This first column will be x, this one will be y, this one will be z. And you're taking the coefficients from each one, and you're just lining them up here. So we have 1, 2, and -1. Here this is -1, 3, -1. This one is 2, 1, and 3. Which method do you prefer to use, the looping method or expansion by cofactor?
The first one.
The loops? Okay. Now, if you use the looping method, you're going to rewrite the first two columns here. And now you can set it up like this, down, plus down, plus down, minus up, minus up, minus up, like that. So you start up here, where the 1 is, and you go down diagonally that way. And now we'll set these up here. You could do the mental math and just multiply them. This would be 9 if you wanted to do that. But I'll set it up like this. In case there's a typo at some point, this will help reduce the chance of the typo in the first place. So then this one would be -1, 1, and -1. And then you do this one here. This one's also going down. So you have 2, 2, and -1. After that, we're going to find the ones that go up. So here there's a subtraction sign from this formula. And you start at the bottom this time with the -1, and you go up this way. So this is now -1, 3, and 2. Then we have this subtraction sign. There's another -1 that we start with. So you have the -1, 1, and 1. And then you start with the 3 here, and you go up. Put the subtraction sign, and this is now 3, 2, -1. Now this is 9 plus 1. This is going to be -4. Here we have a negative, where it's subtracting a negative, so this one becomes +6. Here we have another double negative, and then another double negative, because of the -3 and the -1. So it actually ends up being 6. Let's combine some of these. From these two we'll get 10. These two will be 2. These two will be 7. So here we have 19. This is the d part that goes in the denominator of the fraction, for where we have a dx or a dy or a dc over d. We need to know this one. It's going to go in the denominator of the fractions that are coming up. So far, do you have any questions about anything?
No.
Even though I just did this right here, I'm going to proofread it. And even though it can slow things down, I would say that it's worth doing it, because you don't want there to be any problems. Cramer's rule, like a 3x3, can take a while. So
Yeah.
you don't want to have to do the whole thing over again, just with one thing being off. Everything's fine here. I'll move this over here, but I'll shrink it so that we don't have to look at two different screens. we'll need to refer to this 19 for the next parts. Now for the next part. You're basically taking this part, the blue part here. So we're going to look for the d of x now. We know what the d is, it's the 19. But we need to know what d of x is so that we can find out what x itself is. So you basically do the same thing, but where we have x, you're going to replace this with the constants. These are all going to go here now. We'll have the 3, the 9, and the 11. You still duplicate the first two columns, and you set this up for the looping method. So you're basically doing the same thing again. You start at the top here with the 3. These are the first part, where you have 3 times 3 times 3. And then you do the next part. This is the loop that goes down. And then you do the last part. Then you start doing the subtractions. So these are the parts that go up from the 11. Then the negative 1. This one is subtracting a negative 1, but I'll just write it like this. And then the last one, where you start with the 3. And then you simplify this. This one is 27. Here this will be negative 11. This is now negative 18, negative 66. This is a double negative, so it becomes positive 3. This one's also a double negative, so this becomes positive 27. This ends up being negative 38. So this is the d of x part. The d part is the 19. So we can find out what x is now. X is the same thing as d of x over d. We just found out that the d of x is negative 38, d is 19. You simplify this, it turns into negative 2. So then this is what x actually is. Now I'll shrink this so that we have some space. We're going to look for y. So you start back here with the original again. The difference this time is that since we're looking for y, you have to take the constants and replace the numbers now. This is now 3, 9, and 11. So these constants took the place of the numbers that were in the y column. The first two columns will be duplicated. After that, you go ahead and start the loops. This is the first one going down. Then you have this loop. Then you have that loop. And then you do the loops going up from the negative 1. And then we'll subtract the next loop here, starting at the 11. And then the last loop starts at the 3 and goes up. And then we'll simplify this. This is 27. There's a negative there, so this is negative 3. This is 44. This is a double negative. This is just negative 11. And then this is negative 9 times 2. We'll go ahead and just cancel these out. After that, this ends up being 57.
Yeah.
So this is the dy part. Y is the same thing as dy over d. We already found d in the beginning, that was 19. Now we just found out that this is 57. This turns into 3. So to find z, you would do the same thing where you take these constants and you place the numbers in the z column with those constants.
Yeah.
And then you duplicate the numbers here. And then you could go through the same process to find d of c and divide that by d. But because we already have 2 of the 3 variables, there's a much faster way to do this now. What you can do is go back to the originals, pick the easiest of the equations that you would want to work with. So I'll just pick this one here at the top. And we know that the x is -2 and the y is 3.
Yeah.
This is -5. When you add this to both sides, this is now going to be 2z equals 8. And you divide both sides by the 2. And you get z equals 4. So it's a lot faster. Once you know 2 of them, you can get the third one very quickly. So in this case, we have an ordered triplet x, y, and z. We found out that this is -2, this one is 3, and this one is 4. Here, I'll show you one last thing you can do. This one is an optional step. You go ahead and take the 3 equations, and you're checking x, y, and z in all 3 of them. We have to get 3 true statements. And you go ahead and do the substitutions. We actually found z using this equation, so it's going to work, but still want to check. This is like saying -5 plus 8, or 8 minus 5 is 3. So we have a true statement. Everything's good for this one. Now we have to check the second equation. Or, you don't have to do the step. It's optional, but I would recommend doing it so that you know that you have the right answer. So this is -4 plus 9 plus 4 equals 9. The 2 4's here are opposites. They're inverses, they cancel each other out. The -4 and the 4 are gone, and we have a true statement. 9 does equal 9. And so we now have to check the last equation. We have -2 minus 3 plus 3 times 4. This has to equal 11. This is a double negative, so this becomes +2. And then this one becomes 12. Here, the 2 minus 3 is -1. And then 12 minus 1 is 11. So we have 3 true statements. Having checked it in all 3 equations, we know that this is the correct answer.
Okay.